Yeah, camps on everyone. So, hope all had a good Diwali. Hope all got the sweets. Hope they are up to your liking. Chalo. Anyone who didn't get the sweets, forgot to fill the form, you should regret it. At least next year, fill it up again. Anyway, so that is one. So today we'll be starting with a new chapter, center of mass, momentum, and collisions. That is one. And one more thing, like I said, after Diwali, we are going to shift our timings. So from this Thursday onwards, our timings will be shifting. So it will become 5:30 to 8. You will get a break at 7 o'clock for 10 minutes. Maybe this Thursday, we will have it only for 2 hours. And from next Tuesday onwards, this is a regular timing, 5:30 to 8. At 7 o'clock, I'll give you a break for 10 minutes, approximately during that time, 6:55 to 7:05. So you'll get a 10 minutes break in the middle. Clear? This will be your new timings from this Thursday. I'll post in the group anyways, because we are going to increase the duration from now, because abhi ho gaya. Now the chill out period is done. Now you all be seniors. Your seniors ka portion is done, and now they have an exam in next 2 months. So we will bump up the speed a bit. We will be doing things much faster. So there. So keep that in mind. Timings will be changed. I will be posting in the group also after the class. So let's start off with this. Center of mass collisions momentum is it's a good chapter. It's like, this is a chapter which is a bridge between whatever you have learned till now and the next chapter, rotational mechanics. Like I said, rotational mechanics is the peak. Now, what do you mean by the bridge? For example, say, if I take a incline, smooth incline, and if you keep a block here, what was the acceleration? G sine theta. But the same block, if I keep it like this, do you really think it will slide? There is a chance it will topple like this, right? But we never considered anything like this, isn't it? Whether you kept the block like this or you kept the block like this, we never cared about the dimensions. We always said the block will slide with an axis in G sine theta, but we know in reality it does actually get affected. So till now, what we did was we have considered all the blocks to be point particles and we have solved problems. So if the blocks have dimensions, things are different. So this is the chapter which is going to connect that. So center of mass or COM. So it's a point about which the motion of a body can be split into translation and rotational motion. Now we need to define what is this translation, what is this rotation. So let's see the first one, translation motion. Now most people get confused. They think translation motion matlab you should go in a line. Now understand one thing, translation motion and rotational motion are defined for bodies. They're not defined for particles. Till now, whatever you learned in kinematics, NLM, friction, everything, you have always treated the bodies to be a point particles and you have solved problems. So let me define this. So what is translation motion? If all points on the body move in equal parallel paths, we say the body is in translation. Example, let's say if I have a block, and let's say this block is going in a straight line. So if this is A is gone here. If this is B has gone here. This is C has gone here. If you see, all the three paths are equal and parallel. Suppose if you take a rod here, now if you can look at my screen, if I have this thing here, right? Suppose if I move like this, can you see it is going in a curve? So if I take this rod, and if I move it in such a way, like this, if you see all the paths are equal and parallel, this is also a translation motion. The points are going on a curve, but the rod is going in translation. So don't get confused between translation motion and linear motion. They have no relation to it. Translation motion is defined for a body. If you see the points on the rod are going along a curve. So we call it curvilinear motion. But when you define for a rod, so points on the rod move along the curve, but the rod is in translation. There, that's a simple definition. What is translation? If every point on the body, if all the points on the body move in equal parallel paths, we say the body is in translation. Have a look at this. Let me define all these things. I think there'll be more examples. You'll get a better understanding of this. Any doubts on this page? Next thing, what is rotational motion? Again, this is another big misconception people have. Rotational motion and circular motion are different. Circular motion is defined for a point particle. Particles go in circular motion. Rotational motion is defined for bodies. So this is what I was saying. Till now, work per energy, right? We have never cared about a body actually. When I said, tell me one thing, if I have a block like this, and if I apply force F like this, how did you used to draw the FBD? You used to draw an FBD like this, right? F, mg, n. But tell me one thing, if you apply force, a lot of force, isn't there a possibility that the block can become like this? Isn't that what happens when you try to push a bench or a cupboard or something? That means force F is this, mg is this, normal reaction is here. Isn't it? Normal reaction is not in the center. We have never cared about anything like this before. We always treated the whole thing as a point particle and you solve the problems. You get in the catch? So if this was single point, it won't matter. But when it is a body, it matters. So this chapter will give us now that thing. This will give the centromass will give us that connection between treating a particle and a body. So what is rotational motion? So rotational motion, if every point on the body covers equal angles. Example, if you take a rod and let's say if this rod is swinging. Now, if you observe here, this point A here is going from here to here. This point B here is going from here to here. Can you see? They both are maybe parallel, but they're not equal. A and B cover same angles. Angle is same, but not same distance. Your fan is the best example of rotational motion, ceiling fan. Another example is your ceiling fan. Ceiling fan is in pure rotation. So keep this in mind. Translation and rotational motion are defined for bodies. When I say body, means it should have a lot of particles. These are not defined for particles. In rotational motion is not same as circular motion. I'll use the word extended bodies, meaning a body will have a lot of particles. Clear with the definitions? So what is translation? Every point on the body moves equal parallel paths. What is rotation? Every point on the body covers same angle. So let me give an example. You tell me which is translation, which is rotation. Turn in the page. Case one, let's say we have a rod here, we have a block here, and this is welded here. You took a block and you welded this. A, B, C, D. Case two, this is hinged here. That means it is free to move about it. Meaning, like, how? Ever been to a giant wheel? In that giant wheel, how is the cabin? Cabins in a giant wheel. Meaning, let me show you how it looks. See, for example, if you look at my phone here, when I say hinged, when I say welded, right, it is like this. Now, if I rotate my hand, can you see how it is rotating? Now, suppose if this was hinged like a bolt, you're getting how it is like this, it is free to move. Meaning, if I take this, now see, if my hand is like this, now if I keep it vertical, it is still like this. Meaning, no matter what I do, the phone will be always vertical only, right? Can you see? But suppose if this was welded, if I rotate like this, can you see what is happening? But if this was hinged, see what would happen? It would become like this again. Isn't that what happens in a giant wheel ka cabin? It is just hanging, right? Are you able to understand what you mean by hinged and welded? Now, can you tell me between case one and case two, which is translation, which is rotation? Or both are rotation or both are translation? I hope you're getting the meaning of hinged and welded. So the cabins in a giant wheel are hinged. They're not welded. So between these two, which is translation, which is rotation? Think, take a minute. Okay. Try others. Surya, what is the answer? What do you think? Surya, is there in the class? Okay, not there. He's talking to someone else. Let's kick him out. He's gone. Then, okay, let's see. Let's draw a diagram and see. Again, stick to your definition. So if this was there, now when it becomes horizontal, now if you look at the orientation, if this was A, B, C, D, can you tell me what is this guy? So what will be that one? This will become B, C, this is A, and this is D, right? Agreed? Now, if you look at the paths here, look at the paths. So B has gone from here to here. A has gone like this. Did you see the crisscrossing? These are not equal parallel paths. C is going like this. D is going like this. Right? So, what are these things? These are not equal parallel paths. These are, and if you observe, all of them cover same angle. Now look at C here. So A, B, C, D are in circular motion. All the points are going in a circle. And block is in rotation. This is rotational motion, everyone, because all of them cover equal angles. Yeah, you can say that, but sometimes, there is a chance it can become a combination of rotation and translation also. Look at case 2. Now, how will they look like? This is A, B, C, and D. So this also will be A, B, C, and did you see orientation doesn't change? Now, if you try to draw them, again, I didn't draw it to the scale, but you can kind of see. Can you see they're parallel? They are parallel. They're not parallel. Ahana. I didn't draw it up to the scale, but they're parallel. So if you look at here again, A, B, C, D are in circular motion. If you talk about the individual particles, they are still going in circles. That's what I'm saying. Don't get confused between circular motion and rotational motion. They both have no relation to each other. A, B, C, D are in circular motion. Circular motion is defined for a point, but the block is in translation. All the points on the body travel equal parallel paths. So case 2 is actually translation motion. So most people think like, sir, it is going in a circle, no, so it is rotation. No, it is going in a circle, agreed. But circle is defined for a particle. For a body, you have to look at the all the points there. Have a look at this thing. If a rod hangs from a string in case 1, then it will be if the rod hangs string. Nay, it's still the same thing, right? Matlab, if you're keeping the string straight, it will be still like this only, isn't it? Or you're saying you want to keep the string like this in the center. It depends. Are you welding it? Are you tying it to a fixed point, or are you keeping it in the center to rotate? Clear, na? So basically here, see, if you tie the string to the center like this and you allow it to rotate, it is translation. But if you're just going to tie the string to the top and if you don't let it do anything, then it will be still rotation only, right? Think about it. You can't do like that. If you tie a string here, string will become like this, isn't it? The orientation does change. Clear?
सर
हाँ रे.
सर इन केस टू एंगल सेम ही है ना लेकिन
कहाँ पे सेम हो रहा है गॉड एंगल्स?
द ब्लॉक तो एंगल सेम
This is there, this is there, right? तो ठीक है, एंगल्स कैन बी सेम, सो दैट हाँ एंगल्स तो ये देखना पड़ेगा ना तुझे पूरा एंगल, right? So but the main definition is that equal parallel paths. Angle can be same, that is okay. In this case, if we can see now, the distances are definitely different. Can you see the D ka length is greater than A, na? So D will make a bigger circle compared to A. Huh, Surya? Clear with this? Yeah. I was calling you 3-4 times. You're not responding. So I thought you're not there. Then Vihan said, "Sir, kick him out." So it's not my fault. Next one. Any doubts on this? It's quite an important one. It looks pretty normal, but we're going to use this concept a lot. Later on, when we see these problems, right, we have some pretty good advanced problems on this. Just based on that rotation or not rotation, the whole question will change later on. So not only this, we also have now combination of these two. For example, if you take a wheel which is rolling on the floor, this is V and this is omega. Now, if you take a rolling wheel, I can split this into two parts. I can assume the wheel is just sliding, and I can just assume the wheel is rotating about the center. So I can split the motion into a translation plus rotation about the center. So this is how actually we study the rotating wheel. So now we have combinations. This is a translation plus rotation. What about Earth going around the sun? What do you think is that? If you look at the Earth ka motion from the sun ka perspective, what kind of motion is that? It's a rotation plus rotation, right? The Earth rotates about itself. There is a rotation and there is a revolution. It's a combination of rotation plus rotation. It's a double rotation. Ever been to Imagica? Did you go to this ride? Cup and saucer ride? You have a big disc. You have a small cups kind of thing. You're sitting there. The disc is rotating with omega, and this cup is rotating with omega. It's a rotation plus a rotation. It's a double rotation. Another example of this is your ever seen this table fan? A swinging table fan. So table fan rotates. That is one rotation. It is swinging also. That is your second rotation. So if you look at your table fan, kind of, I won't say it's a table fan, but I'll draw something like this. So if you have a disc like this, see the rotations here. So this disc here can rotate like this, and this whole setup is rotating like this. So it's a double rotation. Are you able to visualize how it is? So basically, a swinging table fan is a double rotation. So you can even have this also, rotation plus rotation. If you look at moon, though, it will be like triple rotation. Moon ka own rotation, moon ka rotation about the earth, and earth ka rotation about the sun. So you can say rotation plus rotation plus rotation. Clear with this? So the fundamentally what you have is translation and rotation. You can create a combination of all that stuffs. Which one? I wrote now these are in circular motion. When did I say it is not? Clear? I hope everyone got an idea about translation and rotation. Now, consider a uniform rod. Is thrown into the air. We observe the system in the universe is also a translation. We can't define like that. Translation. Don't bring the universe into the picture. Na? In universe, nothing is at rest. You can't say you are at rest and I am moving. So because if you say like that, someone will say sun is also moving, then someone will say galaxy is also moving. So let's not make it complex. So we observe a certain point. Goes in a parabolic path. Basically projectile motion. And the remaining points rotate about this. This point is called center of mass. Let me show an example. This is a pretty useful thing when you're trying to study some complex motions. Center of mass actually helps you a lot. It can split the motion between rotation and translation. So for example, think of like this. If you have a rod like this, and let's say you projected this with u and theta. Let's call this point C, let's call this point A, and this is B. And let's say this rod also has some rotation omega. So you're getting how it is? You're throwing this thing like, you're catching the end of the pen and throwing in the air. So this thing will rotate also and translate also, isn't it? Isn't this how it goes in the air? If you take a pen ka edge and if you throw it like this, right, you will observe this will rotate and translate. It does both. Now, if you look at the motion of this, you will notice this point C, right, is going in a proper parabolic path. And if you look at this rod here, this rod is rotating like this. Something of this sort. The rod is moving something like this. So if you look at the point here, this is point B, this is point A, this is B, this is A, this is B, this is A. So this is how the rod is going. Now, if you try to plot the path, let's say if I try to plot the path of A, this is how the path of A would look like. Something like this. And in this, if you see this thing, so this was A, this is that center C. I didn't draw it up to scale, but you got it. So this was C and this was A. Can you see how complex the motion looks like? If you look at the tip of your pen, when you throw it into the air, it's going in a circle. It's making a path like this. It's you can't study this directly, but using this logic here. So C is the center of mass here, which behaves like a projectile. This is what I have been doing till now, actually. Whenever I said a body is thrown with speed u and theta, You calculated all that range, H max, time, range, everything you found for the center of mass. You didn't find for the all the points on the body, which behaves like a particle in projectile motion. So this we have actually found out, like experimentally and mathematically also you can prove this. Whenever you throw a body into there, you'll always find a point called center of mass, which will always follow a parabolic path. It takes the role of a particle. It behaves, that whole point is behaving like a particle and everything else is rotating about it. So if someone asks you to study motion of A or B, this is what you do. So motion of A will be the motion of C, which is a projectile motion, plus the motion of rotation of A about C. So it's a projectile motion plus a circular motion. So when you go and stand on the center, it looks like it is going in a circle. This looks like it is going in a circle. You're getting this? So this is a combination of a projectile motion with circular motion. So you can say like something like this. Have a look at this. So this works. We can always find a point called center of mass, which will exist. Technically speaking, center of mass is a hypothetical point, but we can prove mathematically it always exists. There is certain point there which will always do this thing. No matter what kind of weird shape you take and throw in there, you'll always find one point which is following a parabolic path. It actually makes your life easy. Now you can go and stand on that point. You will see circular motion. You know how to do circular motion, and you know how to do projectile motion. You just add them. I'll show you how they'll frame a question on that. So if you look at this example, look at this. Are you not opening? Yeah. Now see, these people, right, have taken some objects and they're throwing into the air. Look at the first one. So that's a tennis racket. You can see how it is rotating and going. This is some ball with a rod. That is a disc. Now what they did, they painted the center of mass, they calculated it and painted with an orange paint, switched off the lights. Now you can see only the center of mass, isn't it? This was the tennis racket. You can see that small orange spot glowing, that's your center of mass. What he's holding is a tennis racket. Now if you throw this in the air, you won't see all that rotation because it is dark. You only see the spot. Can you see the parabola? There, can you see the parabola again? The whole racket goes in weird motion, but the center of mass will follow the parabolic path. This is that rod and the ball. This is that disc. It does follow almost a parabolic path. Now see that again in the beginning. If you see there, can you see how it is rotating? The whole racket is there rotating. Can you see? It is rotating. There it is rotating. There it is rotating. So that's what I was trying to tell you. So the whole racket is going in some weird motion, but if you just look at the center of mass, it follows a proper parabolic path. I'll share this video also with you after the class. Yeah, you got the idea there. So let's see a question on this. Clear? So this is not something which you're making up. It actually does happen. So let's say you take a rod. This is your C and this is your this is A. You projected this with u and theta. This thing also has omega. So this point is origin 0, comma 0. A ka coordinates are L by 2, comma 0. So this thing starts flying in the air like this. After some time, your rod becomes like this. So A is here. Okay. C is your center of mass. L is the length of the rod. So rod is projected in the air. With speed u, angle theta, angular velocity omega. So you're rotating it also with an omega and you're throwing it in the air. Find the coordinates of A at time t. There. Find the coordinates of point A at time t. Think I'll give 2 3 minutes. How will you do this thing? I hope the question was clear. Try. Just do it. I'll get some water and come. Hmm. Can you find the coordinates of C first? That would be the easy one. That comes from your projectile motion. And you think it's a new problem? You have done this before. Anyone remember? Hmm. Where did we do this? Hmm. Anyone remember this question? Basic maximum. This is a third class. A rod is rotating, speed is given, find the coordinates of A at time t. Remembering the little memory loss patience. So there, we have done these kind of things before. It's not the first time you're seeing. It's been a long time. I can understand you'll forget, but try. I'll give you a minute more. Figure out whatever you can do. It's not. It looks weird and tough, but if you understand it is only a projectile motion plus circular motion, with that idea you will be able to figure out at least some part of it. First, find coordinates of C. Start from there. X coordinate is okay. That looks fine. Ahana. Nee, Ahana, that's not the full answer. You found only coordinates of C, I guess. I want coordinates of A. Everyone should try. Arush, give it a try. Let's see. First thing, if you just look at point C, projectile motion, the coordinate of C will be u cos theta t. You should not forget this thing. You had a problem in finding coordinates of point C, it means you're not revising the stuff. U sine theta t minus half gt square. This is a standard thing. Because C goes in a projectile motion, these are the coordinates. Now, if you look at this, I will just draw the diagram again here. I'll exaggerate the figure a bit. Let's say this rod has rotated an angle theta. Let's call it alpha. Theta we're already using. What is alpha? Alpha is nothing but omega into time, isn't it? Isn't that the definition of angular velocity? Angle covered per unit time. So in time t, the rod will rotate an angle of omega t. Now you can ask me, sir, how did you draw like this? Why can't the rod be like this? That is okay, na? Alpha, time will take care of it. This angle can be acute or obtuse or anything. The angles will, time will take care of it. You don't worry about that. This is your point A. So from here, if you drop a perpendicular, this is L by 2. This will be L by 2 sine alpha, and this will be L by 2 cos alpha. Means, look at from here. Meaning from point C, so whose coordinates are xc comma yc. If you travel L by 2 cos alpha forward, you will get xa. If I travel L by 2 sine alpha upward, I'll get xa, isn't it? So I can simply say the coordinate x coordinate of A is x coordinate of C plus the extra distance L by 2 cos alpha, which is u cos theta t plus L by 2 cos omega t. Similarly, y coordinate of A will be y coordinate of C plus that extra vertical distance L by 2 sine alpha. This is what I was saying, a circular motion plus a projectile. So this guy will be u sine theta t minus half gt square plus L by 2 sine omega t. Check. This is how you do. Now you can find the coordinates of anything. You find the coordinates of the center. From there, make a circle and then figure it out. Anyone not convinced with this, please ask me. So once you can split the motion into a projectile, that is translation, and a rotation, you know what to do from there. Clear, everyone? So great. So we kept on talking about this center of mass. You can split center of mass. You can do that. Great. But how do you find this center of mass? One, there's an experimental of figuring it out, and there's also mathematical of figuring it out. But let's see how to do this. Turn in the page. Any doubts on this? So the first thing, locating center of mass. So let's say we have particle M1 with a vector R1 bar, M2 vector R2 bar, Mn vector Rn bar, and so on. So the position vector of center of mass. And in case you forgot, what is the position vector R bar? X coordinate I cap, Y coordinate J cap, and Z coordinate K cap. M1 R2 plus so on till Mn Rn bar by M1 plus M2 plus so on till Mn. So this can be written as simply sigma Mi Ri by sigma Mi. Mathematically, this term is called weighted average. And normally, average meaning you would have just taken R1 plus R2 plus Rn by N. Weighted average meaning you are giving value or weightage even to the mass. So higher the mass, the more that R1 vector will dominate. So it is called weighted average. Meaning, think of like this. Let's say we all are stuck on an island. Okay. Let's say I am stuck on an island with a first standard kid. And we both have 100 kgs of food there. Now, equality says I should get 50, he should get 50. And then what will happen? First, I will die, and this guy will survive. Because he's a kid, he can't save himself from all the small animals, he will die. Done. Both are dead. Getting. So, what is a fair way of dividing then? We see what is my mass. Let's say my mass is some 80, and this kid ka weight is, let's say, 30. So, based on our weight, we divide the food ka ratio, and we say the point is, I need to save the kid. For that, I need to be alive also. If I eat too much, the kid will die. If I give too much to the kid, I will die. If I'm not there, the kid won't survive. So you're getting the game. So the point is to maximize the survival of both of them. Meaning the best case would be we either get saved by someone or both of us should live as long as possible. So the final limit would be like this: both of our food should get over at the same time. Something of that sort. So we divide the food based on our weights. So we call this thing weighted average. You don't divide by equal. You don't say two people are there 100 by 2. That's your normal average. Kind of makes sense. So it is a mathematical term. It's called weighted average. So this is how you find the center of mass ka position vector. Now, if you put a delta on both the sides, that is a change in center of mass. Will be sigma summation. Mass generally remains constant. So change in the position vector of each particle. Quite a useful one. We are going to use this a lot. So should definitely put a star or something for this. So this is a change in center of mass. So basically displacement of center of mass is Mi into displacement of each particle. Have a look at this. Then now, if you just want to find the particles, now see, this is how we can divide this. If you're finding center of mass for particles, the x coordinate of center of mass will be m1, x1, m2, x2. So instead of using r bar, we use this x coordinates. So you can simply write this thing as sigma mi xi, sigma mi. Similarly, y center of mass will be sigma mi, y coordinate I by sigma mi. Similarly, sigma mi zi by sigma mi. This is for particles. If you have continuous bodies, Again, what is a continuous body? Rod, disc, these are extended bodies. Now for these things, the formula changes a bit. So x center of mass, instead of using sigma, it becomes an integral. Instead of using m, it becomes dm, and this will be x. And if you look at the formula mathematically, they're the same thing. Sigma, summation of particles, integral, summation of small particles. Mass, mass, x coordinate, x coordinate. This is the summation of total mass, this is the summation of total mass. So sigma becomes integral. So here x is the x coordinate of the dm mass. Of that small part of dm mass. Next class is quite important. Huh? Next class, we are going to see all these integrations. First time in physics, you will be handling like, how to actually choose elements, how to integrate and everything. And that you're going to use it literally everywhere. It comes in rotation, comes in fluid, electrostatics, magnetism, gravitation, everywhere. So next class, with the integrations part we'll be seeing, and that will be the whole basis of everything. Without those kind of integration elements, how to choose and how to solve, you won't be able to handle advanced problems in physics. So next class we will be doing it in pretty detailed, how to integrate stuff and how to choose elements. So that is one. So make sure to revise your calculus notes and come once. If you remember this part I was talking about. Do you remember this areas and volumes part in calculus? How to choose an element, onion car rings, non-uniform disk, for a sphere, how to take an element. So this stuff again I'm going to repeat. But I think you should revise once and come, it will help you a lot. And that part will just keep coming everywhere. So quite a useful one. Y center of mass will be integral dm by. Physics में integration is easy. The headache is always finding an element. Integral, this is dm, z by integral dm. So when you have extended bodies, use this formula. If you have particles, use this formula. So there are two formulas for them. Clear? Let's see some basic questions today. And then we'll write down the properties also. Any doubt so far? Great. Next time. Let's see our question. Let's say we have m here. Let's say this is a comma 0. This is 2m here, which is 2a comma 0. Find the center of mass. Easy. What is x center of mass? M into a, 2m into 2a. Total mass is m plus 2m. So that would be 5ma by 3m. 5a by 3. What is the y coordinate? Both are 0. So it is 0. Meaning the center of mass is somewhere here. But what do you mean by this actually? For example, if you make a dumbbell, let's say make a dumbbell of mass m here and mass 2m here. Kidding? It's a dumbbell with unequal mass. Now, if you remember in the beginning, I told you, whenever you throw a body into there, center of mass is a point which will make the projectile. Everything else will go in a circle. So this point will go in a circle, in a parabola. And if you look at this dumbbell, this is how it would be. Meaning this 2m will be going in a smaller circle. This m will be going in a bigger circle. So everyone is going in a circle, but they'll be going in a circles of different radius now. This is how the motion will be. You're getting it? So center of mass goes in a straight line, circle parabola, and the dumbbells, the balls will go in circles of different radius. It's unequal mass. M and 2m go in circles of different radius. If the mass had been uniform, they would have rotated about the center. Because the 2m is more mass, it gets closer to that. So they will go in different circles. I hope you're getting the point of center of mass. So center of mass ka primary objective is you can use center of mass to split the motion into a translation and a rotation. Makes your life easy to solve questions. If you try to study the 2m ka motion separately, this thing will go in such a weird path. I don't know what to do with this. But the moment I know that center of mass is going in a circle, parabola, and 2m is going in a circle, your life becomes easy. Is this clear, everyone? Any doubts on this? Next thing. Easy one. So this is your x-axis. This is your y-axis. This is an equilateral triangle, side A. This is m, 0, 0. This is 2m. This is 3m. Find the center of mass. This is a cube of side A. So m is the center of these two, 2m is the center of these two, and 3m is at the face center. A, B, C, D. Find the center of mass. Let's get them both. Again, if you know how to find the coordinates, question is over. So we have three masses m2, m3m on an equilateral triangle, three masses m2, m3m on a cube. Side A. Find the center of mass of both of them. Get them. I'll give you 2-3 minutes. Yeah, first one. हाँ, you can simplify that a bit more, right, निहारिका? वो 3/12 4 हो जाएगा ना? 3√3a/12 is √3a/4, right? Right. Keep going, keep going. Get the cube also. It's easy stuff. There is nothing there. You just need to know how to find the coordinates. We have done this thing in, where vectors, how to find coordinates of a cube, if you remember. Let's see. See. So first let's get the coordinates. So this guy will be 2a comma 0. This will be the center here. This will be a/2. The height of a triangle is √3a/2. This much you should know. What is x center of mass? M into 0. 2m into a. 3m into a/2 by total mass is m plus 2m plus 3m. I'll stop writing this later on. So how much is this? This is 2,437a/12. Similarly, y center of mass is m into 0, 2m into 0, 3m into √3a/2 by 6m, √3a/4. Great. How to find the coordinates for this cube? Now, for people who don't know, listen, this is how you find normally the coordinates. If you travel, let's say like this, from origin, if you travel along y-axis, only the y coordinate will change. Make sense? So E ka coordinate will become 0, a, 0. Now from here, if I travel towards right side, I'm traveling along x-axis. And how much am I traveling? Only a/2. So m ka coordinates will be a/2, a, 0. That is how you find the coordinates. From the origin, if you travel along x-axis, only x coordinate will change. If you travel along y, only y will change. If you travel along minus z, only it will subtract. So from here, if I continue to go further, I will get b ka coordinates, which is a, a, 0. Now from there, if I travel towards 2m, I'm traveling along z-axis. So that is a/2, a, a/2. Hope I'm right. Now from there, if I go to 3m, now see for 3m, what am I doing? I'm going like this, and then coming down. I'm traveling in the y-axis negative direction. So a ka coordinate will be a. Wait, 2m I goofed up. This is also a actually. A, and then I'm going down. So this is a/2, comma. Wait. B का coordinate is a, 0. I need to go from 2m, right? Okay, a/2, a/2, a/2. Make sense? Check your coordinates. When you travel to E, you're traveling only in y-axis. So only y coordinate will change to a. When you go to M, only a/2 will increase in x-axis. When you go to B, it will become a, 0. From B to 2m, it will be a, a comma z is increased by a by 2. When you come down, you have to subtract y by a by 2, and you're done. Now, what is x center of mass? You can multiply. So m into a by 2, 2m into a, 3m into a by total mass. How much is that? 5 plus half, 11 by 2, 11 by 12. Yeah, 11 by 12. What is y center of mass? 5a by 12, 3a by 4. M into a, 2m into a, 3m into a by 2. So that is a 2a plus 3a by 2. So 3 plus 3, 3, 2, 2, 9. A plus 2a plus 3a by 2, 3, 2, 6, 9a by 2, 9a by 12, 3a by 4. Z center of mass will be, that would be a plus 3a by 2, 5a by 12. Check. Easy. There's nothing there. Like I said, once you know the coordinates, question is over. Any doubts on this, please ask me. Next one. Clear, Ariman? Arush? Arnav? Surya? Vignijit? Clear with this? Ojas? Nikhil? Let's see one more. So we have a square x, y. This is 0, comma 0. Let this be mass m. Let's call this point A. This is 2m. Let this be B. This is 3m. C. This is 4m, and this is T. Now look at this. Find center of mass of system AB. So I want you to find the center of mass of A and B. Now it looks silly, but it's a very powerful statement that we'll get from here. And find the system for C and D. And then find the center of mass of system AB and CD. Means I'll tell you what I'm asking you to do. Find the center of mass of these two, I'll get something. Find the center of mass of these two, I'll get something. And then I'm asking find the center of mass of these two. And then we are going to prove this will be the center of mass of all four of them together, which kind of makes sense, right? But it's a very useful statement to prove. Let's prove it. Find the center of mass of AB, CD, and then find center of mass of AB and CD together. And we will prove that that is the center of mass of ABCD. Let's get this. I'll give you 2 minutes. Done. Let's find for AB first. So for AB, X center of mass will be m into 0. Meaning I'll just write on the coordinates. So this coordinates will be a comma 0. It's a square. A comma A, and this is 0 comma A. 2a by 3, and the y coordinate is 0. If you do the same thing for CD, clear? These are the coordinates of these two. Now, what do you mean by find for AB and CD? So this is what it means. So listen carefully. So for this M and 2M, you got a center of mass here. So you can replace this with a 3M ka mass at 2A by 3 comma 0. That is the meaning of it. You can just replace both this M and 2M with 3M ka mass and solve the problem here. So you can treat this like a new particle whose mass is 3M and the coordinates are 2A by 3 comma 0. Similarly, you can treat this as a new particle of mass 7M whose coordinates are 3A by 7 comma A. And now we are trying to find the center mass of these two. Is that making sense? So the center of mass of ABCD will be 3M, 2A by 3, 7M, 3A by 7, 3M and 7M. This comes out to be A by 2. If you take YABCD, this is 3M into 0. This is 7M into A by 10M, 7A by 10. This is the center of mass. And you'll observe this is the center of mass of ABCD. If you have taken all the 4 and solved it, you would have got the same answer. Clear, everyone? So what does this give you exactly? So listen carefully. So we'll put down all the properties of center of mass now. So this is the first property there. So if you have a system is divided into n parts. Now listen carefully. It will sound weird, but I'll explain you. The center of mass of the center of mass of the n parts is the center of mass of the system. Meaning, what is that again? See, so let's say if you have a lot of particles here. So what I'm suggesting is, let's say if I divide this into n parts. Now each part will have its respective center of mass. So this will have its center of mass C1, C2, C3, C4, C5, C6, C, and so on. So I can replace all this with a particle C1, C2, C3, so on till Cn. Now for all these particles, there will be one center of mass. Making sense? This will be the center mass of all particles. Kind of making sense? So basically we can treat the n systems can be treated as n particles. So what is the use of this? So the use of this is, if suppose someone creates a system, right, which looks weird, but when you break the system into pieces, you can find the center mass of each piece. For example, suppose if you give me a rod like this, can I just see and tell where is the center of mass? I can't. But what I can do here is I can say this vertical piece is one rod plus this horizontal piece is one rod. And then I will say for a rod, I know the center of mass C1. I know for this rod, the center of mass is C1. And then I will say, let's find the center of mass of C1 and C2. Is that making sense? So you can divide the system into parts, and each part ka center of mass, if you can find somehow, then treat them as particles and solve. If I give one more example, suppose if I give you an inverted ice cream cone like this. Now look at the shape. I can't find a center of mass for this, but what I can do, later on we will learn how to calculate. We know how to calculate center of mass for a cone. You know how to calculate center of mass for a hemisphere. So we will find center of mass of this thing. So this is the center of mass of cone. We will find center of mass of hemisphere, and then we will say there are two particles here, C1, C2. And then I know how to find center of mass for particles. I'll get my answer. Is this making sense, everyone? So in JEE, there is a question like this. I think 2008 or 9. They said there is a ring. They said there is a rod. There is a rod. There are two particles. And they said find the center mass of this. This was a JEE question. So the idea was for the ring, we will find center of mass. For the rod, we'll find center of mass, center of mass, center of mass, center of mass. So remove the ring, remove the rod. So we got five particles, right? You find the center of mass of these five particles. This is how you do. Making sense? So when you do your booklet, you will find the PYQ like that. Have a look at this page. So this is quite an important thing, quite a useful one. So if you give me some weird system, I can break that into some pieces which are symmetrical and I can find the center of mass. So this is one of the property there. Clear? Any doubts on this page? Clear, na, Pratik? Ishana? Aryaman? Arnav? Ahana, clear? Taksha? Great. Next one, going ahead. So let me write one more property. So center of mass is a point about which weight seems to act. No, this is important. It seems to act, okay? It doesn't actually exist there in a uniform gravity. So for all problem solving parts, we can assume the weight is at the center of mass and solve the problems. So that is while drawing FBDs, we can, mg vector, we can draw mg vector from center of mass. That means, suppose if you take an example of this guy. Now, technically, if you see, the weight is acting everywhere. DMG, 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 DMG. So all the small masses, right? The weight is everywhere. It becomes very difficult to solve this, but keep your life simple. We will just say, on an average, all this weight that is acting, now I can say center of mass is here, and I can simply draw mg here. And you can solve the problems. You can say this is a normal reaction, and then you can do all that stuff. So, but technically, if you see, there's no mass there. The center of mass is not in there in the body also. But for problem solving, it works. The entire problem behaves as if the mass is acting from there. So then comes our next point from here. So there need not be mass at the center of mass. So like I said, center of mass is a mathematical thing which you calculated. And it works. So this point need not be on the body. There need not be mass also on the point. There need not be mass at center of mass. Like this example. And it need not be on the body. It can be, but there is no compulsion like body पे compulsory होना चाहिए. And if you take an example, a ring Or if you take a boomerang, something like this shape, you will clearly see the center of mass is here, there. You can't touch it also. Center of mass is somewhere here. So there need not be mass at the center of mass. It need not be on the body. But for problem solving, it works. Just like pseudo force, it works. The whole system behaves as if the mass had been there. Clear? Any doubts on this page? Then, if I go one more point, sometimes you'll keep hearing this word called center of gravity. Technically, if you ask me, right, center of gravity is more powerful than center of mass. But then again, it becomes a little complex to study. We call this thing COG. We don't have this in the portion, but just a basic idea you should know. Maybe I'll teach you a problem of this in gravitation. So it's a point about which the net force acts. But for all general purposes, right, it's almost the same thing. Point about which the net force acts. The catch is in uniform gravity, center of mass and center of gravity become the same. And generally, most of the time on the Earth's surface, gravity is uniform. You have to go really high to change gravity. So for all technical purposes, you can they work are same. So when does this change happen? Let's say you make a 1,000-kilometer building. I know, hypothetical. If you take a very tall building, then you will start seeing things. If you take a tall building, now the floors on the top will experience less gravity, whereas the floors at the bottom will experience more gravity. That means the bottom part of the building is experiencing more force compared to the upper floor. So this actually gets messed up. You can't say it is symmetrical. Now, in that case, what would happen? The center of mass will be in the middle. The center of gravity will come slightly downward. So if this was the midpoint, center of gravity will be slightly down because there's more force at the bottom. Because there is more force at the bottom. So center of mass assumes the gravity is same everywhere. So it will be at the symmetrical thing. Center of mass will be at the center. So that is a major difference. Center of mass assumes everything is uniform. Center of gravity will take care into the account that the force is also changing. So that's what it said. Center of gravity is more powerful. But like I said, the structure has to be pretty large for the gravity to come into effect. On Earth, even if you go 10 kilometers high, gravity barely changes. It gets affected in some second or third decimal. So it is fine. There's another thing. So center of gravity, we'll see later on how to calculate that. Also, I'll teach you in gravitation. So you need to have a thing where gravity changes. Clear with this? Any doubts on this page? Next one. Let's say one more. So if you take a two-particle system, center of mass always lies along the line joining them and between them. Meaning, if you take mass m1, if you take mass m2, you can be sure the center mass will be on this line. If you take this distance to be r1 and this distance to be r2, you always get this m1 r1 is equal to m2 r2. They'll be in this ratio. More the mass, the closer the center of mass. for uniform triangular plates. These are all the properties of center of mass. Center of mass is at the centroid. This is for a plates. So even if you make something like a scalene triangle, the center of mass will be at the centroid. There, have a look at this. Clear, everyone? Turn in the page. Janil, clear, na? Nikhil? Next thing. Center of mass always lies on the line of symmetry. If there are two lines of symmetry, it is on the point of intersection. Example, let's say if you take even that boomerang thing, you can clearly see. What do you mean by line of symmetry? When you draw that line, left and right should look identical. So either side of the line should look same. That's called line of symmetry. Now, I'm pretty sure center of mass is somewhere on the line. I don't know where. I can't tell you the y coordinate, but I know the x coordinates on this thing. For example, if you take a disk, it has multiple lines of symmetry. Any diameter has a symmetrical line. So this is symmetry. This is also symmetry. So I can be sure center is a symmetry. So somehow if you can figure out two symmetrical lines, then you're done. Get the answer. Center of mass always lies within the extreme boundaries of the system. This is how you'll get theoretical questions. What do you mean by extreme boundary? So let's say if you have a lot of particles, and if you just join these extreme particles, you can be sure center of mass will be somewhere here. It need not be on the body, but it will be within the extreme boundary. Again, if you take the same boomerang thing, so here your extreme boundary would be this point, and this point. So if you just join them, you can be sure center of mass will be within this. It need not be on the body, but it will be within that extreme boundaries. It cannot be outside this boundary. This actually comes from that formula only, m1, x1, m2, x2. If you're saying it is going out of the boundary here, means you're saying this x coordinate is greater than this. And that formula m1, x1, m2, x2, you can't have an x coordinate greater than this. It's like kind of saying, not a relevant example, but it's like imagine your teacher comes and tell you in the class, everyone should get above average in the class. Can you see the problem with that statement? Happens, teacher tells you everyone should get the more than average in the class. Not going to happen. The only way you can do this, if all get equal score, then everyone will be equal to average. You can't get less, all can't be greater than average. There's last point here. This is also a good one. If a body is suspended by a thread, Now it doesn't matter what kind of body, irregular, non-uniform mass, anything. If body is suspended by a thread, the line joining center of mass and the point of suspension is always vertical. This is actually a pretty good technique to find center of mass for any weird shape. So if you take some weird shape like this, and if you tie a thread like this, so what the statement says is, this is your point of suspension, this is your center of mass. The line will, the vertical line will always pass the center of mass. Let's say if you take a rod like this, and if you suspend this, the center of mass will be here. Something of this sort. I didn't draw it properly, but I hope you got the point. Something like this. So this is your point of suspension, and that's your center of mass. The line will be always vertical. Means from the point of suspension, if you drop a vertical line, it will pass the center of mass. So if you give me some weird shape like this is what I will do. First, I will tie a thread here. I will draw a line. Then I'll remove this. I will suspend it in another position. I will draw a line. So I will get two lines. The point of intersection is the center of mass. Make sense? So that's how you can look at the center of mass if you give me some any irregular shape or non-uniform mass also. So these are the 1, 2, 3, 4, 5, 6, 7, 8, 9 properties of center of mass. And there, you know how to do for a particle now. So in the next class, when we catch up, we are going to do for non-uniform bodies like, rods, arcs, sphere, hemispheres, all this stuff. Quite an important session. Like I said, especially we'll be using integration. Like that is the first time you'll be seeing integration of that level. Like it's not calculation again, choosing elements and stuff. So it will really help if you can revise this and come. It will be, you will be able to get the hang of it. You can just go through all this stuff, page 93 till page 118, calculus. Revise this, right? So on Thursday, when we catch up, we will start from this. We will be doing all that stuff. Okay, so with that is there. Again, just to give a reminder, we timings are changing from Thursday. Our class ka timings are becoming 5:30 to 8. Some of you have come late, so you will get a break at 7 for 10 minutes. Maybe this week I will leave you, a little early, but next week, say these are the timings. Tuesday, Thursday, 5:30 to 8. This is something which we discussed before, so we need to extend the timings now because you guys become seniors. Just, and then that is there. And last week there are two papers, remember? Hope you all have resolved that. So Thursday we will discuss those paper doubts also.